All right, here we're going to look at example 4 where we subtract rational expressions. This is quite similar to what we did in example 3 where we added up the expressions that had unlike denominators. We still need to find an LCM, which in turn is our LCD, our least common denominator, and then we can work on combining the expressions. There's going to be a lot of factoring involved, combining like terms, distributing, multiplying. We're always kind of keeping the domain in the back of our minds. But it is very similar to example 3 with one major exception or major difference because we're looking at the difference, we're looking at subtraction. So this first term, we're going to have x plus 1 over x squared minus 6x minus 16, and then we're going to be subtracting x plus 1 over x squared plus 6x plus 8. So we do need to be careful. Always have common denominators before you are combining through addition or subtraction your rational expressions. So what we need to do is we need to factor our denominators. So my numerator is going to remain x plus 1, and I now need factors of negative 16 that add up to negative 6. I mention it all the time. I'm not going to go into much detail with the factoring because I've mentioned it in previous videos. So if you do have questions on the factoring, just refer back to those. But in this case, factors of negative 16 that add up to negative 6 would be negative 8 and a positive 2. The order wouldn't matter. We're just going to write them, or I'm going to write them that way for now. And then we want to do the same thing for our second fraction. We need to find factors of 8 that add up to 6. So in this case, that would be x plus 2 and x plus 4. So we've now factored our denominators. We can start looking for an LCM. So I'm going to do some highlighting here. I see that I have an x minus 8. There's no other x minus 8. I see I have an x plus 2. So I'm going to match that up with the other x plus 2 so I don't list it twice. And then I also have this x plus 4 term. So my next step when I'm subtracting, I'm going to subtract using the LCMs. So my denominator, I have 3 colors here. I have the minus 8, the plus 2, and the plus 4. So I'm going to list all 3 of those as my LCM. Kind of cramming this in here a little foolishly, trying to write this too small. So we have this x minus 8, x plus 2, and x plus 4. X minus 8, x plus 2, and x minus 4. Let me just write that a little bit larger. So we have x minus 8, x plus 2, and x minus 4. So let's keep this color-coded so we don't lose track of anything. Okay, so my numerator in the first term is this x plus 1 that I'm going to put in parentheses. And I need to see what was new in the denominator. So what wasn't in the step before but is there now? Well, that x minus 4 is new. So since it's new to the denominator, I need to also introduce it to the numerator. All right, we want to be careful with that. So we need to keep equivalent expressions. If we don't do that, then we're now changing the value of our fractions, and that's not what we're looking to do. So we have x plus 1 and x minus 4. Oh, sorry, that should be a plus 4. Apologies there. This should all be plus 4, x plus 4. Okay. Now my second fraction, we have another x plus 1 we're bringing down. And then again, what is new from here to here? The only thing I notice new is that x minus 8. So we're going to put in that x minus 8 there. And we're going to color code it because I keep pointing that out. All right, now from here, there's a couple different ways you can go about this. You have to be incredibly careful with the subtraction sign here. So what I would recommend in this part of the problem is that I'm going to actually distribute my numerator. Okay, I'm going to multiply everything out. So I'm going to FOIL the numerator in each expression, and this will become x squared plus 1x. Sorry, let's go in order. Plus 4x plus 1x plus 4. and then my denominator stays the same. I'm not going to, don't FOIL or distribute your denominator. Leave it as the LCM. You don't want to do any extra work. So the second one, I'm going to do the same thing. It'll be x squared minus 8x plus 1x minus 8. Write my LCM again, or my LCD. It's a lot of work, a lot of writing here. Next, we would combine like terms. So I'd have x squared plus 5x plus 4 over, get my LCD. Just bear with me on this. And numerator here, x squared minus 7x minus 8. And again, don't change your LCD. Leave that alone. Okay, so let's keep continuing. And what we need to do here now is we're subtracting, but this subtraction sign goes to this entire numerator. So we have to be incredibly careful in this step. So what we're going to do is we're going to subtract, and there's going to be a lot of writing here. So my denominator is going to be the same. That makes my life a little bit easier. However, my numerator, be very careful here, it's going to be x squared plus 5x plus 4. I like putting each group in parentheses because it helps me keep track of things, minus this x squared minus 7x minus 8. And this is where we save ourselves any type of work because, or any type of potential mistakes, because we're subtracting this entire expression. So you have to think of it as that's a -1 that gets distributed to each of these terms. So my numerator is now going to be x squared plus 5x plus 4 minus x squared plus 7x plus 8. And then I would get x minus 8, x plus 2, and x minus 4. Once again, we're not doing anything with the LCD. We're just going to leave it alone. Be careful on this step. All right, outside of finding the LCD itself back here, this is the critical, most crucial step, is that when we're subtracting, we actually subtract that entire expression, not just a piece of it. So now we can combine our like terms. Let's look at some highlighting here. So these x squareds are going to cancel out, right? We have x squared minus x squared. My numerator, I have a 5x plus 7x, so that's going to be 12x. And then I have a positive 4 and a positive 8. So 4 plus 8 is going to be 12. My denominator, again, we're just going to keep bringing that along for the ride. Oh, I did it again. I don't know why I keep writing this as x minus 4. This should be x plus 4. So if you're following along here, just be careful with those ones. I originally wrote subtraction signs. Sorry about that. I don't know why I keep doing that. Now, once we've combined all our like terms, we did this in the previous video, we do need to check to see if anything can be factored, because there is the chance that things can be reduced. So we're going to factor our numerator, and that's going to be a common factor of 12. We're left with x plus 1. And now we have x minus 8, x plus 2, and x plus 4. There's nothing common between the numerator and the denominator, so nothing can be canceled out, but we do always need to check that. So that's going to be our final difference between these two rational expressions. When we subtracted them, we get that number there. The other thing we do need to just take one final note of is the domain. So the domain would be all real numbers, except, and we can go back to the LCD for this, we can't have a positive 8, a negative 2, or a negative 4. And that's going to be our domain. So I know this is not the most enjoyable type of problem. Tends to be a lot of steps. The nice thing is it is just a series of factoring and adding, subtracting, and potentially multiplying. So examples 3 and 4 are very, very similar to one another. You see that we found an LCM or an LCD. We combined our numerators through whether it was addition or subtraction. And then the final thing we had to do is once we combine like terms, we needed to factor one last time to see if anything could be reduced out. The major thing you have to look out for in a subtraction problem is that subtraction sign. Just make sure that you're subtracting the entire numerator, this whole piece here, and not just the first term. And that's it. Try it for. It'll give you a good idea of what's going on here. A is a little tricky. You're still finding LCDs. This time you just have 3 terms. So keep that in mind. Be careful with that, and I think you'll be fine doing these.